Good morning, one and all. Now we are going to share sampling design for legal research. In legal research methodology, sampling design for legal research in legal research methodology. The primary purpose of the legal research is to discover principles that have universal application. For this, the data has to be collected and analyzed. There are two methods of data collection in legal research methodology. First one is census method, second one is sampling method. Goodday and Hart defined a sample as a smaller representation of large whole. Non-Lin defines it as a subject of case from the population chosen to represent it. Thus, the whole group from which the sample has been drawn is known as universe or population, and the group selected for study is known as a sample. Once again, we repeat the whole group from which the sample has been drawn is known as universe or population method. The group selected for study is known as sample method. A population or universe is a set of large number of objects or the total number of conceivable observations of any kind or possessing some common specified characteristics. The sample should represent the characteristics of the population as closely as possible, like a reflection in a mirror to the original. Sampling is used when the researcher has to collect or gather information from a wider area. Second one is the researchers does not require 100% accuracy. Third one is the population is homogeneous. Fourth one is it is not possible to adopt census method. The sampling method was first introduced and used in social research in 1754 AD by Bowley. BOWLEY. The sampling method was first introduced and used in social research in 1754 AD by Bowley. Assumptions underlying sampling. Assumptions underlying sampling. First one is homogeneity amidst complexity. Homogeneity amidst complexity. Second one is possibility of representative selection. Possibility of representative selection. Third one is absolute accuracy, not essential. Fourth one is independency or interchangeability. These are four kinds of assumptions underlying sampling. Number one is homogeneity amidst complexity. Two is possibility of representative selection. Three one is absolute accuracy, not essential. Fourth one is independency or interchangeability. Merits or advantages of sampling. Number one, saving of time. Number two, less expensive. Number three, detailed study. Number four is accuracy of result. Number five is administrative convenience. Number six is impossibility of the use of census method. Number seven is scientific base. Demerits or disadvantages or limits of sampling method. Number one is chances of bias. Number two is need of specialized knowledge. Number three is difficulties in sticking to sample. Number four is less accuracy. Number five is impossibility of sampling. The criteria to be kept in mind in constructing a sampling design. The criteria to be kept in mind constructing a sampling design. The researcher should follow the following criteria in constructing a sampling design, such as follows. Number one, selection of the sampling units to be included in the list. Number two, fixing the optimum size number suitable for his study. Number three, in terms of scientific standards, sampling procedures which don't provide a sound basis for estimating sampling error should be avoided. Number four, measurable or known probability sampling techniques be used, that is quota sampling or stratified non-random sampling. Number five is unduly elaborate and complicated techniques should be avoided and should be careful to use simple, straightforward, workable methods properly adapted to avoid fallacies. Number six is every attempt should be made to achieve maximum reliability of results for the amount spent and the availability of time. The characteristics of the sampling unit have been discussed here under. Characteristics are essentials or qualities of a good sampling unit. According to Calvin, the two major characteristics of a good sampler, one is it must be representative of the universe or population. If the sample is not a representative, it will be considered as a biased sample. Second one is it must be adequate in size in order to be reliable. The other characteristics which the units of sample should possess are the unit should be clear, unambiguous, and definite. Fourth one is the unit of sample should be suitable for the problem under study. Fifth one is the unit selected should be standardized if possible. Sixth one is the unit should be easily ascertainable. Seventh one is the unit of sample should contain independent character. 8 is it should have homogeneity character. Number 9 is the unit of sample should have the same chance for inclusion and be selected on basis of mathematical law of chance or probability. Number 10 is the samples selected should represent the different areas of the universe. Procedure to select a sample. Following steps have to be taken in selecting the sample. First one is preparation of source list. We must have a clear idea of the universe or the whole group from which the sample is to be drawn. The universe should be a definite universe, that is, the units can be definitely ascertained. The units of the definite universe should be listed out. This is called the source of list. The source list should possess the following qualities. Number 1, the list should be exhaustive. 2, it should be up to date and valid. 3, it should contain full information about the units. 4, the units should not be repeated in the list. 5, it should be suitable for the particular study. 6, it must be reliable. 7, it must be within the reach of the researcher. Procedure to select a sample we have discussed. Number 1, preparation of source list. Number 2 is deciding the sampling unit. Before drawing a sample, we have to decide the unit of sample. We have to decide which type of the following sample units to be selected. Number 1 is geographical units. Number 2 is structural units. Number 3 is social group units. Number 4 is individuals. Number 3, selecting the sampling techniques. After deciding the sampling units to be selected from the source list, we must use one of the following sampling techniques to select the sampling units. Number 1 is purposive sampling. Number 2 is random sampling. Number 3 is cluster sampling. Number 4 is multi-stage sampling. The selection of sample have to be made following the above steps and statistical sampling techniques. Size of the sample. The size of the sample is an important issue as it has a direct bearing upon accuracy, time, cost, and administration of the research. According to Parton, an optimum sample is one which fulfills the requirements of efficiency, representativeness, reliability, and flexibility. A large size of a sample is no necessary insurance of its representativeness. Small sample properly selected may be much more reliable than large samples improperly selected. The size of the sample is influenced by the following factors. Factors affecting the size of the sample. Number 1 is nature of population. Number 2 is number of classes proposed. Number 3 is nature of study. Number 4 is practical consideration. Number 5 is standard of accuracy. Number 6 is size of the schedule or questionnaire. Number 7 is nature of cases to be conducted. Number 8 is type of sampling method used. If absolute random sampling is used, a much larger sample is required. If absolute random sampling is used, a much large sample is required. If stratified sampling is used, reliability can be achieved in a much smaller size. Parton has given the following formula for calculating the size of the sample. Size of the sample is equal to PC into 100 minus PC into Z squared bar T squared, where PC is equal to preliminary estimates of the percentage from the universe. Z is equal to the number of standard error units which are found to correspond to the required probability. R is equal to margin of error which may be tolerated 5% or 2%. Parton has given another formula for calculating the sample size for estimating the mean of the universe in regard to a specified characteristics within a given margin of error with a given probability. The formula is given below. Sample size is equal to comma Z by D integrated squared. where gamma is equal to preliminary standard deviation of the universe, z is equal to number of standard error units corresponding to the required probability, t is equal to margin of error to be tolerated. In fact, no rigid number can be prescribed for an optimum size of the sample. The size of sample is entirely dependent on the nature of the problem. Biased sample. The bias may be caused in the sample by any one of the following reasons. Number one is too small size, two purposive selection, three imperfect stratification, fourth one is incomplete source list, fifth one is replacement or undue loss of cases, sixth one is selection of cases by field workers, seventh one is convenience sampling, eighth one is faulty method of drawing random sample, ninth one is nature of the phenomena. To make sample representative, one should avoid these sources of bias in sampling. Sampling depends upon the skill of the sampler in bringing the representativeness in his selected sample. Types of sampling. Sampling methods are broadly divided into two types. Number one is probability sampling. And number two is non-probability sampling. Probability sampling is method. It is possible to state in advance the probability that any given unit will be included in the sample. Once a probability model is set up, a mechanical procedure is devised to select elements from the population. The probability model is set up having in mind number one, the type of the universe, number two, characteristics of the units, number three, objectives of the study. Within this probability sampling, there is a random sampling. A simple random sample is selected in such a way that each person in the universe has an equal chance of being selected in the sample. According to Parton, Parton, according to Parton, random sampling is the form applied when the method of selection assures each individual or element in universe an equal chance of being chosen. Random sampling is not the same as chance selection. The random suggests a selection without any system of design but does not mean haphazard, careless, or unplanned. It is also called as proportionate sampling because each class of item of sample is in the same proportion in the universe. When the universe is composed of different groups of extremely varied sizes, the method cannot be successfully used. Methods of drawing a random sample. There are four methods generally used in drawing out a sample on random basis. Number one is lottery method. Number two is random numbers. Number three is selection from sequential list. Number four is grid system. Precautions in drawing a random sample. Number one, the population to be sampled should be clearly defined and be listed. Number two, different units should be approximately of equal size. Number three, units should be independent of each other. Number four is every unit should be accessible. Advantages of random sampling. It is free from bias, it is generally more representative, it is very simple to administer. Assessment of sampling error can be made statistically. Disadvantages of random sampling. It is very difficult to have completely cataloged universe. Number two is cases selected may be too widely dispersed. Third one is if units are not different in size, this method is unsuitable. Systematic sampling. Systematic sampling requires that the population be accurately listed in such a way that each element of the population can be uniquely identified by its order. A systematic sample consists of a selection of each term from the list. Here sample is selected at every sampling interval. This method has an advantage over random sampling if neighboring observations resemble one another. This method serves almost the same purpose as stratification in distributing the sampling units more evenly over the entire population. Advantages. Number one is reliability of information obtained from systematic sampling is adequate. Number two, it is time and money saving device. Disadvantages. Number one, often systematic sampling gives misleading information. Number two, exist bias. Stratified random sampling. In this method, the population is first divided into a number of strata based on same characteristic such as age, sex, education level, etc. Then a sample random is taken from each stratum and such samples are brought together to form the total sample. While simple random sample is quite representative, a stratified random sample is still more perfectly representative. Once again, I remind it, while simple random sample is quite representative. Yes, stratified random sample is still more perfectly representative. Stratifying process. First of all, we should note the different variables involved in the study of the problem. Second one is the population should be grouped on the basis of common characteristics. The common variables used for stratification are generally region, income, sex, etc. Third one is the in selection of the units of stratum, the simple random method should be followed. One, the size of each stratum in the universe should be large enough. Number two, stratification should be conducted to achieve perfect homogeneity in the different units of strata. Number three is the number of cases or units selected from each stratum should be in same ratio. Number four, the strata should be free from overlapping. Kinds of stratified samples. Number one is proportional stratified sample. Number two is disproportional stratified sample. Number three is stratified weighted sampling. Number four is optimum allocation of sample. There are advantages in stratified sampling. Greater representativeness of the sample is assumed and it makes the occur in the simple random are avoided. Greater precision can be achieved with fewer cases in case of more homogeneous population. We can reduce the cost in terms of money and energy in interviewing respondents due to stratification. Fourth one is in stratification, more reliability can be secured. Disadvantages of stratified sampling. Bias may be caused in the sample through improper stratification. Number two is attainment of proportion is very difficult in this method. Number three is an undue weightage makes the sample unrepresentative if weightage is given to some strata. If the strata are not very clear cut, it may be difficult to divide in which stratum any particular unit is to be placed. The fourth one is cluster sampling or subsampling, a sampling procedure in which the sampling unit is a cluster of elements, and after selecting a sample, cluster information is collected on each element in the sampled clusters is called cluster sampling. For example, for selecting burglars for study, we select some jails in each state by random sampling methods, and information is collected from each burglar kept in that jail. For example, once again I remind the illustration. For example, for selecting burglars for study, we select some jails in each state by random sampling methods, and information is collected from each burglar kept in that jail. Advantages of cluster sampling. When sampling frame of all elements is not available, we can resort only to a cluster sampling. Number two, cluster sampling is economically cheaper. Number three is there will be saving of time. The field work period will be lesser. Disadvantages of cluster sampling is number one is the efficiency of cluster sampling is lesser compared to sampling by elements. Number two, due to unequal sizes of clusters, building of estimates are somewhat difficult. Number three, usually the elements within a cluster are similar. As such, in cluster sampling, cross section of the population represented in the sample is less. Multi-stage sample. It is a method of subsampling in each sampled cluster, a sampling technique in which we first take a sample of cluster and then do subsampling in sampled cluster is known as multi-stage sampling. It is an advancement of over the cluster sampling method. Multi-stage sample. This design is used for sampling in large-scale surveys. Next one is non-probability sampling. In this technique, sample is not based on the probability with which a unit can enter the sample, but by other considerations such as common sense, experience, intention, and expertise of the sampler. The main defect of such samples is that they are biased samples. The following techniques represent the non-probability sampling. Number one is representative sampling. Number two is judgment sampling. Number three is accident sampling. Number four is purposive sampling. Advantages of purposive sampling is proper care will be taken in selecting the sample. The purposive sampling is at times of very cheap. It is more useful, especially when some of the units are very important and must be included. Fourth one is care can be taken to keep out any bias. A disadvantages of purposive sampling is the knowledge of the population may not be available. The controls are often effective and a biased sample is selected. Estimate of sampling errors rests upon hypotheses which are seldom met in practice. Convenience sampling. Sample is selected according to the convenience of the investigator is called as convenience sampling. Self-selected sampling. Selection of sample is made among the samples that were selected. Self-selected sampling. Selection of sample is made among the samples that were selected. Then quota sampling. QUOTA, Quota sampling. In this method, both stratification and judgment is used. In this type, samples of prefixed size are taken from each stratum of the universe using judgment sampling method. Once again, I remind it, Quota sampling. In this method, both stratification and judgment is used. In this type, samples of prefixed size are taken from each stratum of the universe using judgment sampling method. Advantages of Quota sampling. There is the benefits of stratification without the high field cost. There is no necessity to use much technical knowledge. Freedom is there to the enumerator to select the samples. The estimates can be obtained quickly and cheaply. The services of the enumerators can be easily exploited. Disadvantages of Quota sampling. Theory of sampling cannot be applied to Quota sampling. Information about the precision of estimates through this method cannot be obtained. The reliability of the estimate is not known. It is dangerous to use this method without sufficient experience. Area sampling. In area sampling, small areas are designated as sampling units and the households to be interviewed will be selected if they are found in a canvas of these designed small areas. Area sampling. In area sampling, small areas are designated as sampling units and the households to be interviewed will be selected if they are found in a canvas of these designed small areas. Next one is sampling by regular intervals. Another procedure is to select the cases at regular intervals from a series, alphabetical list, or any other arbitrary arrangement is termed as sampling by regular intervals. Reliability of sampling. The sample must always be reliable and representative in character. Reliability of sample can be tested by size of sample, homogeneity, representativeness, and the error. Error can be measured as sampling error and standard error. In reliability of sampling, first we are going to sampling error. In a sample survey, a small portion of the population is studied. Though the sample is a representative of the whole, the results of the sample are bound to differ from the census results and there exists an error. This error is attributed to fluctuations of sampling and it is called sampling error. The sampling error is present only in the sample survey and is completely absent in census method. The sampling error is present only in a sample survey and sampling error is completely absent in census method. Sampling error may arise from chance or bias. There are unbiased sampling errors also. The unbiased errors are subject to the law of statistical regularity and tend to eliminate one another if the sample size is increased. Sampling errors are primarily due to the following reasons. Number one is faulty selection of sample. Number two is substitution. Number three is faulty demarcation of sampling unit. Number four is error due to bias in the estimation method. Number five is variability of the population. Now we are going to say measurement of sampling error. Absolute error is the difference between actual value A and estimate value E. Absolute error AE may be positive or negative. Relative error is the ratio. Relative error RE is equal to absolute error A minus estimate value E by estimate value. RE is equal to A minus E by E. It may be positive or negative and is often expressed as a percentage. A measure of the sampling error is provided by the standard error of the estimate. So measurement of sampling error is absolute error is the difference between the actual value A and estimate value E. Absolute error A minus E may be positive or negative. Relative error is the ratio. Relative error is equal to RE is equal to A minus E by E. A is equal to absolute error. E means estimate value. So RE is equal to A minus E by E. It may be positive or negative and is often expressed as a percentage. Next we are going to say standard error. Standard error. A measure of the sampling error is provided by the standard error of the estimate. The standard deviation of the sampling distribution of a statistic is known as its standard error. The standard deviation of the sampling distribution of a statistic is known as its standard error. For example, the standard deviation of the sample mean is called the standard error of the sample mean. For example, the standard deviation of the sample mean is called the standard error of the sample mean. The standard error of the statistic measures the extent to which we expect the value of the statistic from the different samples to vary due to the chance error in the sampling process. The standard error indicates not only the size of the chance error that had been made, but also the accuracy we are likely to get if we use a sample statistic to estimate a population parameter. Standard error provides an idea about the unreliability of a sample. The greater the standard error, the greater is the departure of actual frequencies from the expected ones. Hence, the greater the unreliability of the sample. The reciprocal of standard error, that is 1 bar SE, is a measure of reliability or precision of sample. The value of a summarizing measure based on a sample is known as a statistic. It is probable value. It is an estimate value. The universal value of a summarizing measure of the kind is known as a parameter. The universal value of a summarizing measure of the kind is known as a parameter. The degree of variability of the cases in a sample also has an important influence on the reliability of the measures computed from the sample. The standard error is a measure of reliability. The standard error of the measure is theta x is equal to theta root n minus 1, means the mean value of the sample. N means the sample size and means the mean value of the sample. In correlation cases involving 30 cases or more cases, the form of standard error of Pearson coefficient of correlation is theta r is equal to 1 bar root of n minus 1 cm or 2 centimeter. On the right side should be left out. Once again I remind it. In correlation cases involving 30 or more cases, the form of standard error of the Pearson coefficient of correlation is theta r is equal to 1 bar root n minus 1 cm or 2 centimeter. On the right side should be left out. Any notes, if required, can be written along the margin or the foot with the help of standard error. We can measure the error of the sample. After deciding the method of data collection, the researcher decides the sample size if the sampling method is selected, and then he prepares to collect the data. Till now we have shared the sampling design for legal research in legal research methodology. Go ahead, rule your arena. Thank you.